almost everyone in the room manages the European honeybee. And so I want to talk about, it's not all about the European honeybee. If you look around the globe, there's a lot of other types of bees that are managed. And so I'll take you, and we'll go around and look at some of the other bees that produce honey, et cetera, et cetera. In the middle, I'll throw in a little bit of other information that I hope you'll find useful. So yeah, it's just, we're going on a travel log, sort of, travel log. So it's not too dense, kind of light. But, and it also lowers our carbon footprint because we don't have to, we can visually go to these places and not have to fly. Only honeybees? No. So we're used to honeybees. We know how to manage them. We know how to harvest honey. But there's many other types around the globe, and I'll touch on those. And then the second part, I'll talk a bit about colony defense. Like we know what our bees do with hygienic behavior and stuff, but I'll talk about some other bees and some of the defense mechanisms that they use to fight off predators and stuff. So I think you'll find that part, I hope you'll find that part pretty interesting. And I forgot to lead in, do we have the interpreters ready for because I'm speaking in this poor American English, and I'm not using very proper terms, but I'll do my best, and I'll try to use my normal voice and not back to my roots in Georgia, which is very slow, and we really draw things out. So I'll try to make it clear. Humans have managed bees for thousands of years. We hunted and gathered, and then we started bringing them into apiaries, and this is in the Jordan Valley, and it was a site within an old city, and when they dug down, they found all these 3 rows of clay cylinders. If you look a little closer, the clay cylinders are, in fact, beehives. There's more than 40 hives in this right downtown area of this small community. So this type of beekeeping, almost commercial beekeeping, has been around for a long time, and this is in Guy Block and colleagues published this in PNAS in 2010. But it's a fascinating story. And then as they dug down through the layers, you know how you do archaeology, you dig down slowly, 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 and they found these very well-preserved dogs down there as well. So. But this is a picture from modern-day Egypt. This same type of beekeeping still exists. It's still productive. It's low input. The bees swarm in. They close them off with mud, things like that. They come back and harvest. So it's a very sustainable kind of beekeeping. You don't need a movable frame hive. So that's, 2,000 years of the same kind of beekeeping. Most of my talk, I'll focus on most of the different groups of apis. So we do Apis mellifera, and the other cavity nesting bee on your far left, the cavity nesting bees are Apis mellifera and Apis cerana. And maybe in Apis cerana, the Asian honeybee, there's more than one big species, but it's debatable. And then I'll talk about the open nesting or single comb bees, the bees that build either a big single comb, which are the giant honeybees, or the one that build these very small, almost the size of your hand, dwarf honeybees. So I'll talk a bit about those and their habits and stuff. What else produces honey? Honeypot ants in Australia, which are kind of rare, but they're there. And then stingless bees are all throughout the tropics. And they're actually kind of making a comeback. Humans have always managed them, but the value of that stingless bee honey is very high, and people are beginning to manage them more and more throughout the world in the tropics. So first, these honeypot ants. Eric Trunel, a great photographer from France, said he went and did a study on these honeypot ants in Australia. And the Aboriginal people can recognize the sand layer under the tree if the ants are there. So they can walk through the outback and find where the ants are by the something about the color or the shape of the sand and stuff around their nest. But what the ants do is go out and collect nectar and come back, and they feed certain of these ants, and they just fill them with nectar, honey. And they just hang there as kind of like food reserves. And then the Aboriginal people have found them over time, and they go in, they uncover them, pick them out, a nice little sweet treat in the outback. So they don't rob the whole nest. They go in, take a few of these honey pots, and enjoy them. And this is some of the artwork. You've probably seen some of these dream schemes, but they're depicted in there. You see the two dark bands on these are the ants, that they work with in the environment. So they're not really managed, but they're hunted and gathered. Bumblebees produce a small amount of honey, but no one really harvests honey from bumblebees. They're more for production agriculture, more production agriculture. But stingless bees, on the other hand, stingless bees are managed, and there's many different species, and I'll show you a few pictures. The honey's higher in moisture content. It's often harvested with a syringe or something because it's highly valuable, but the people treat it almost as medicinal purposes. The one really beautiful thing about stingless bees is just the variety of nest. Trigona is one of the big species, Melipona, genus, and they have all these different nest architecture, and almost all the entrances that come out of a tree have these resin tubes. So that's at the end of a resin tube. So that's primarily for ant control and stuff. They guard those tubes. But this type of beekeeping is becoming more and more popular. People are understanding how to make colony divisions, things like that. And it's the value of the honey is the reason there's a resurgence. Honeypot ants, stingless bees. Now we're going to go into the single comb nesting bees in Asia. Another quick point. If we think about the globe, North and South America had no apis. They have stingless bees. North and South America had no apis mellifera, no nothing. Europe and Africa had Apis mellifera. That's where Apis mellifera is. All the other apis are in Asia. So Asia is the most diversity of apis. And these two giant honeybees, Apis dorsata and Apis laboriosa, they all build nests that can be at least this wide and this deep. And if you go online, you can see some beautiful pictures of people climbing cliffs and harvesting this kind of honey. This picture also shows they cluster when they nest often. So you'll find like this, maybe it had 30 nests in this one tree. We don't understand exactly why they cluster in because they have other trees they could nest in. Probably has something to do with defense. And a guy in Australia did some study. They do tend to come back to the same location. These bees migrate. So during one season, they're in one area, and then they'll migrate from the highlands, say, to the lowlands based on the rainfall. And they tend to come back to the same area. They have a very interesting defensive behavior. So they have a curtain of bees that hangs on the outside. That you see the bees all hanging there. If you approach the nest, they start to shimmer, and they start in shimmer. So as you get closer and closer, the shimmering picks up, and if you get too close, they attack en masse. So they'll just all of a sudden all leave the curtain and come and attack. If you want to go online and look at this, when a hornet comes, they do small shimmering. So the hornet will come right at the nest, and they'll shimmer in one part just to scare off the hornet. But if you walk up to that nest and they start shimmering more and more, it's a signal you need to beware. The other thing with Apis dorsata, it's mostly hunted and gathered. It's not managed so much. So this is people selling the brood. They sell the honey, obviously, but they also sell the brood as food from Apis dorsata. They hunt and gather it, and they sell it in the markets as food. They tend to harvest sustainably, if you will. They only take part of the nest, not all of the nest. Depends on the hunter. And again, this idea that when you get too close, they hesitate, and then they attack en masse. And of course, I was there, and as a scientist, I want to know what the sting is like, because these are very big bees. So I took a dorsata and stung myself, and I took a mellifera, and there's 2 red dots on my hand. It wasn't all that. It wasn't dramatically different. And so the Apis dorsata is on that side, and the mellifera is over here. Okay, now the 2 small dwarf honeybees. There could be other species, but most people recognize Apis florea and Apis adreniformis. They're slightly different in color. The nests are literally like a small salad plate. They're not very big. Again, the bees hang and cover the outside on the, they form a curtain. One interesting thing to think about, if you've got dorsata or you've got these florea nesting in the tropics, exposed, what do they do when it rains? They do something called, I call it shingling, I think that's what it's called. If you look, all of them have their abdomen pointed down. So what they do is they literally just stand there and they have their wings, they're kind of like a curtain, and their wings are down and the rain just sheds off. So it's a very effective way of shedding rain, even though they're totally exposed in the environment. And interestingly enough, if you take a swarm of Apis mellifera, our honeybee, and you see it in the rain, they'll do the same thing. They'll turn head up and they'll shield the rain a bit. They're not as good as these bees, but they will shield the rain. This is the exposed nest in a hand and a drone comb being built down here. They have a small mite that's similar to varroa called U varroa that infests them. But they're fascinating little bees. I've never been stung by those, and they seem to be very, very gentle. Mostly here they harvest the entire nest because it's so small. So they'll go and clip the whole nest, shake the bees off, and take this into market to sell. One other thing about the nest, this is the top of a pop bottle. When the bees are on the nest and they're trying to do a foraging dance, they come up on top of this honey. The honey's up here at the top, and they dance across the top up here to give direction. So they dance on the top of the comb. And then lastly, you've got these two species, and they overlap in nature. And this is how they build this honey up at the top. One of them builds it with straight cells, and the other one builds it in this kind of rainbow pattern, whatever. And that's the primary difference in the nest architecture, is just this little bit of difference in the way they build a nest. But they're everywhere. If you go into the tropics in Asia, they're easy to find, they're in the bushes, and they seem to do quite well. And what's odd to me is that there's some overlap in the two species. You find them, both species in the same place sometimes. Now back to cavity nesting apis. So you've got two big groups, Asian honeybee and European honeybee. And in the Asian honeybee, there could be more than just Apis cerana. There's Apis cerana japonica in Japan, but there's some other species that have been identified, but I'm just lumping them now as Asian bee and European bee. They all nest in cavities, and they all build multiple combs. So this is Apis cerana in some rustic hives, and this is Apis mellifera in movable frame hives. And this is Apis mellifera European bee in China. And why is that bee in China? Honey production. So it's like that in many parts of the world. Humans have moved, we move bees obviously to North America, South America, but here they've imported it into China for honey production. We're going to Japan now because they manage both bees there, and I was lucky enough to do a sabbatical in Japan, and I'll tell you a little bit about why I was there. But in Japan, they mostly manage, or they almost all manage bees in one box, and they harvest from the sides when they make enough honey. They also have magnificent bee trucks that they use, very small but very well decked out. This fellow was producing royal jelly in an apiary, and they do have bears there. This is on the North Island of Hokkaido. Sapporo is the main city, and they have a bear fence, so he's producing royal jelly. The hive has these special ventilation things in it, and they all seem to use the same hive type. They have hornets there. They have multiple species of hornets there, and the beekeepers really complain about these hornets. So they have several different trap designs to try to ward off the hornets. And we were just in France, and the same thing there. They've adapted all these types of one-way traps to try to reduce hornet pressure. There's another picture of trap. They use some baited traps with just some scented material that the hornets go into. And these are to let the bees out, but keep the hornets out, or trap the hornets. So the reason I was there is they were losing colonies on this North Island. It's heavily agricultural, and they grow primarily buckwheat and rice. And the beekeepers, the colonies were weak, and they didn't understand why, and they suspected pesticides. So I went, and we found bees foraging on the rice pollen, but not at great levels. But there's all these field margins, and what I thought was, here we'll see a little bit about rice paddies. They use these small helicopters, which is kind of nice to apply the pesticide. So they fly over the rice paddy and apply, in this case it was a neonic. And because neonics are water soluble, I thought they must be moving from the rice paddy into these field margins. So what we did is we sampled all along these field margins in rice and in buckwheat, and it was a total bust. We came away with no good answer, but that's kind of like science. So we know the chemicals were there. They weren't really getting in these side pants. So the conclusion was, in this case, on this North Island, pesticides were not directly involved in what they were seeing. So it had to be something else, maybe viruses or whatever. But it was nice to just see another form of beekeeping. And this is back to my thing about we manage one big species, Apis mellifera, and then as you know, Apis mellifera, dark bee, and Apis mellifera adansoni, one of the Africanized bees. There's so much difference in the speciation that has happened over from Africa to Europe. So there's just a wide variety of bee types, if you think, even within our European honeybee. So a bee from Tanzania is not going to do well in Germany, that kind of thing. Just trying to drive that point home. And even though we as beekeepers, we work with bees and we manage them and we think we're improving them, in reality, they do quite well on their own. I mean, bees left to their own devices will usually survive. So we as beekeepers need to learn to listen to the bees, see what they need, and adapt our management to their needs, kind of thing. So I was going to say a little bit now, switch gears and say a little bit about colony defense. This is not the hornet that's coming through France, and I guess it's on the southern shores of the UK now. Has it made it into the UK a little bit? Yeah. This is not the same species, but about the same. It looks about the same. We've talked about Apis mellifera, and we talked about Apis strana, European and Asian honeybee. The Asian honeybee has an interesting defense mechanism with these hornets. So the hornet comes in, the bees are kind of on guard at the entrance, and when the hornet comes close enough, this is Asian honeybee, they grab the hornet, they ball it up, and they heat the ball, and they literally kill the hornet with heat. So there's some nice videos online about that. And our bees, so far as we know, don't have this kind of heat balling behavior, but the Asian honeybee does. So it's because that hornet and the Asian honeybee have co-evolved, the Asian bees have a really nice defense mechanism for Asian hornet. I want to tell you another little quick story about some of the defense mechanisms against a hornet, again by Asian honeybees. And this is a good friend of mine, Gard Otis, and his colleagues, and Heather Madela, and they were doing work in Vietnam. And they were working in these Apis cerana colonies, and they noticed that some of the hives had stuff on them. They were kind of, and they kept asking, what's on those hives? And the locals told them what they thought it was, and I won't tell you exactly that, but I'll show you how they set up an experiment to find out if it was true. So this is a clean hive front, and the bees are inside. And what they said, what the local Vietnamese people said is, when the hornets come at a certain time of the year and they start to attack the hives, that's when the speckling on the hive, that's when they start coating the hive with this material. So you go from a clean hive front to a hive front that looks like that. All this speckling all over the hive front. And the speckling is cow dung or chicken dung. The bees literally, when the hornets come, they go out and collect chicken shit, cow shit, whatever. They collect about 3 or 4 different kinds of manure and put it on the front of the hive. So, I mean, it's really fascinating behavior if you think about it. What it does, what we think it does, is it confuses the hornets. They don't smell the hive as well. And they published a couple of papers on this now, and they were claiming that it was tool use by bees, which is pretty close to it. You've got some event happening, and the bees run off, and they grab the manure with their mandibles, come back. Yeah, it's pretty fascinating behavior. And here they are gathering some of the dung, and they don't collect it on their legs. They collect it, little balls in their mandibles, come back and stick it on the hive. So only, as far as we know, only in Asian honeybees. Our bees don't do that. I've never seen it. So one more defense mechanism. So this to me was very fascinating behavior. This last one I was actually directly involved in. And we noticed when we were looking at hives that were in poor health that some of the hives had what we termed entombed pollen. So this is normal looking pollen. And over here is pollen cells that are dark. All these pollen cells are very dark. And the darkness comes from, they've covered the entrance, or covered they've sealed them off with propolis. So what we did, we went in and took some of this pollen and some of the other propolis covered pollen, and we analyzed it, what was in it. And what we found was a high level of fungicide. So I'll show you that in the next slide. So this is the control. This is the normal looking pollen. And I've got 4 different pesticides down there. Fluvalinate, which we use in hives. Coumaphos, which we use in hives. Chlorpyrifos is an organophosphate. And this is the fungicide. In the entombed pollen, the entombed cells, fluvalinate went up, coumaphos went up, and chlorthalonil went way up. So 2 things. One is the bees recognized that cell was different. I don't know that they recognized the pesticides per se. They recognized that the cell was different, and they sealed it off, so that's encouraging. The other thing is we think it was driven by the chlorthalonil, and that's because we were sampling like very close together. The cells were not very far apart. We think what happens is this chlorthalonil changes the dynamic of the pollen in there, and it draws the coumaphos and fluvalinate out of the beeswax. Because there is coumaphos and fluvalinate in most beeswax. But it doesn't show up here because this is only pollen. But here we think it was being drawn out. But regardless, the bees recognized that something was wrong with that cell, and they used a defense mechanism, which is just to seal it up. Just as if they would seal up a mouse or something. When you're a dead mouse on the bottom board, they'll cover it with propolis. So here they were entombing this pollen and ignoring it, not eating it. So another defense mechanism. You know about their stinging defense, but they have a lot of different defense mechanisms. So we manage one type of bee, but as you go around the globe, there's many, many different types of bees that are managed, especially these stingless bees. If you ever get a chance in the tropics to see stingless bee management, it would be worth seeing. We manage multiple boxes, and we manage supers and stuff. But I would guess that the majority of the world manages bees in a single box. Not even in supers. They just take honey from the outside. So there's a lot of different forms of management. We're going to continue, because of just global trade and everything else, we're going to continue to move things around the globe, and so we can continue to expect some new pests and diseases. Not that we have to worry about them, but we're not going to stop world trade. And so what I would encourage you to do is just work with the bee that you like. Hopefully it's a locally adapted bee. Hopefully it's a bee that works well in your environment. We get hung up on color and things like that, but it's really a bee that survives your winter and works well. So again, enjoy your bees, and don't think that somebody else's bees are always better over there. So I'd say breed locally adapted stock.
Is the Apis cerana that's found, say, in Nepal and other parts of Cerana, does that also bore the Asian hornet? Because I thought it was just the Japonicus one that did that. Do both species of Apis cerana do the same thing with the
That's a good question.
hornet?
Yeah, so the question was, because certainly Apis cerana japonica does the heat balling. That's where they first detected it.
Yeah.
I don't know that, whether or not, like in India or other parts, whether that cerana heat balls or not. It's good. It's a good
I
question.
haven't come across it, so I just
Yeah.
wanted to. The other one was, you mentioned that there's 2 in Japan. They manage both mellifera and Serrana.
Yeah.
Have they found difficulties with competition between the two species?
Not to my knowledge. They tend to, the beekeepers that I've met, they tend to be one or the other as far as they either want to only manage mellifera or only manage Serrana. But I don't know about a competition like for full resources and stuff. I couldn't say. Is that what the question was? Yeah.
I was asking, yeah.
Yeah.
Thanks. Tom.
Yeah. A very interesting thing in Japan. This is way back, but some of you will remember. You remember the tracheal mite? The tracheal mite? Isle of Wight disease? Bailey? Anyway, so it did and can affect Apis mellifera. I mean, I've seen it in the States and other places. You know, if the bees get weak and the mites are there, and I did some work on it for my PhD, but tracheal mites can affect Apis mellifera. All of a sudden in Japan, somehow, they're having trouble with Apis cerana. Asian honeybees are dying from tracheal mites. I'm like, and I met with these researchers. It's same old story. I think it's that the tracheal mites got kind of newly somehow introduced, crossed over into Apis cerana, and they're having problems with Apis cerana and tracheal mites, which is bizarre to me. Yeah, anyway.
When you were in Japan, another question on the Serrana and the European honeybees. Did you notice any difference in the way they managed them for varroa?
With Serrana, they didn't necessarily do any management for varroa in Serrana.
Yeah.
But in mellifera, yes, they were managing, to keep varroa levels down. Yeah.
Okay, thank you. Yeah, interesting.
You don't need to in Serrana.
Yeah, exactly. Yeah. Serrana deals with varroa very well without treatment.
Apis dorsata, the brood from Apis, is sold at the market as food for whom?
So you get these nice pieces of, usually not larval stage, usually late pupal stage, pink-eyed or whatever. You can request, it's kind of like requesting a rare steak or medium rare. No, you get, say, pink-eyed, purple-eyed pupae, and it's in comb, and you can either eat it fresh, people were eating it fresh, and they were also steaming it. So just, I don't know if you saw in the picture, so there was the brood there. On the side were these giant hornet nests, and the grubs of those are as big as your thumb. And the same thing, they steam them, and they eat them. There's a lot of insects used as food. Giant water bugs are sold in markets, and they're crunchy. I've only tried them once. I had to try them once. But I know people who make like a souffle out of drone brood. So you just harvest a drone brood and make a kind of a souffle, and it's protein.
I just wanted to say there's a problem with the EU regs and the UK regs, even since Brexit. You can only import honey that is from Apis mellifera. And I know people who tried to import honey from Serrana, and they couldn't bring it into the EU or the UK.
So I hope you heard the question. So Codex, the ones that set the world standard, they only recognize honey as coming from Apis mellifera. And they're in Rome, and we've tried to work with them that say, the next thing you need to change is you need to recognize that Apis cerana produces honey. And it's very similar. The honey is not that much different. We can maybe get to the stingless bees and all these other bees later, but we need, Apis cerana is not recognized worldwide as producing honey. It's a problem.
Actually, that was the question I was going to ask. Is there any a variation in the honey? The other thing is, do the other honeybees, do they turn their pollen into bee bread?
Bee bread. Yeah, I mean, the Serrana would turn it into, kind of turn it into bee bread. I don't know about the stingless bees. The stingless bees, I know they pack pollen and stuff, but I don't know how the pollen's handled. I just know in mellifera and Apis mellifera and Apis cerana, they would pack it in there and use it kind of as bee bread. There's a piece of research, I don't know, it's about 2 years old now, that shows, I always thought, I grew up thinking that they bring in the pollen, they mix things with it, it kind of ferments and turns into bee bread, and then it's better used by the bees. There's a pretty good paper out that shows if you give bees a choice, they'll always consume the fresh pollen first. So the preservative, making it a bee bread, is for more just for long-term storage and to have it available. But if your bees are bringing in fresh pollen, they've got bee bread, and they need pollen, they'll need pollen to rear brood, they'll use the fresh pollen first, which was new to me. That's a fairly new finding. But yeah, both bees, as far as I know, convert things to bee bread. Yeah.
Why is the honey from the stingless bee so highly prized, valued? Just rarity, or is it special?
It's almost like vinegar. I mean, some of it tastes, it has a little bit acidic and stuff. It has to do probably with the rarity. Each type of stingless bee, the honey will be slightly different, 22 to 25% moisture, so it's very liquidy. And I think it's just cultural that people could go and they could harvest this marvelous sweet substance, and then they, over time, it's like, but I mean, any honey is good. It's good for humans. And so they just, I think it's just culturally that they believe it's medicinal, and it probably is partly medicinal.